Okay, 4.5 is called analyzing lines of fit. So in 4.4, in the last lesson, I talked about what a scatter plot is when you plot a bunch of data points like this. And then a line of fit is a line that roughly fits those data points, okay? All right, so we've got something called a residual. And that's going to be the difference between the y-coordinate of a data point and the corresponding y-coordinate of the line of best fit. Okay, so that means the residual is going to be the data point y minus the line of fit y, the corresponding ones. Okay, so scatter plots of residuals. If we've got a good line of fit, the residuals are going to be more or less evenly dispersed around the x-axis when we graph them. The worse the line of fit, the less evenly dispersed those residuals are, and we'll get to that in this problem. I'll explain what I mean by that, okay? But in this graph, line M is a line of fit for these data points, okay? So here's my line of fit. So the coordinates of the points on the x-coordinates of the points on the line are filled out. And actually the y's are too. If you look at the point 0, 5 is on the line, and then the point 1, 4.5, and the point 2, 4. So this would be 2, 4. These are all lines that are on points that are on line M, okay? But then I want to fill out the data point y's. The data point y's, if I look at this, this point up here is the point 0, 6. So when x is 0, the data point y is 6. When x is 1, then I've got 4.5, it appears to be, for the data point. So I'm going through these. This would be the point 2, 3. Okay, my next data point is 3.5. And then I've got 4. So, 4, right? X and Y. And then I've got 5, 2, 6, 3, and finally 7, 1.5. Okay. So now that I've got the y's for the data points and the y's for the line of best fit, I can find the residuals, because I'm going to take my data point y minus my line of fit y. So I'm going to take this y minus that y to find my residual. So that my first residual here is going to be 1. Okay? And now I've got 4.5 minus 4.5. I'm just subtracting these two y's from left to right. 3 minus 4 is going to come out negative. That's negative 1. 3.5 minus 3.5 is 0. I've got 4 minus 3 is 1, and 2 minus 2.5 is negative 1/2, negative 0.5. 3 minus 2 is 1, and 1.5 minus 1.5 is 0. Okay, so I set up this chart so that I could just do that subtraction from left to right to find the residuals. Okay, and now we're going to get to the place where we're going to see if this is a good line of fit or not. And it's a judgment call, but you can get a sense for if we've got a good line of fit or not if my when I make this graph, if my points are going to be close to the x-axis and evenly dispersed. Okay, so I'm going to look now. I'm going to plot the x's and the residuals. So if you look at the x and the residual from that first from this first row, my x is 0, my residual is 1. So I'm going to be plotting the point 0, 1. Well, here it is, right? And then I've got 1, 0. So 1, 0 is right here. 2, negative 1. 2, negative 1. 3, 0. 4, 1. So 4, 1 is right here. And then 5, negative 1/2, 5, negative 1/2, 6, 1, and 7, 0. Okay, so you can see how these points look like they're pretty well evenly dispersed around the x-axis. So when you plot the residuals and your x-coordinates, if for a good line of fit, it should be evenly dispersed like that. So my answer here is yes, and the reason why the points are evenly dispersed around the x-axis. didn't plan that out. I should have written that down here. Okay, I was off screen there a little bit. So that's what I was trying to explain this piece. Those are evenly dispersed. Okay. All right. All right, let's try another example then. So again, we've got a scatter plot and a line of fit that's graphed, and we want to see if this is, we're doing all of this to see if this is a good line of fit for these data points or not, okay? So it tells us the equation of the line is y equals x plus 1, okay? So we can use this equation to find the ordered pairs, okay? You can also just look at the graph, but you could use the equation if you wanted to as well. All right, so let's find the data point y's. We've got the x's from 0 to 7. So let's look at the data points first. So this data point would be 0, 1. So when x equals 0, y is 1. Then I've got 1, 3. So when x is 1, y is 3. This is 2, 0. And this is 3, 8. This would be 4, 0, 5, 2. And this is 6, 6, and 7, 8. Okay, so those are the xy pairs from the dots, not from the points on the line. Okay, so now I'm going to look at the line of fit x's and y's. So that point is on the line, so I can use these points that are actually on the line. I want to look at these xy pairs. Okay, so I've got when x is 0, y is 1, and it's going to be going up 1 from there because my y's are going up 1. So this would be the point 1, 2, and then 2, 3, and maybe you can see the pattern happening here. So this is going to be 4, 5, 6, 7, 8, right? And now let's find the residual. So now we're going to do the subtraction from our data point y's to our line of fit y's for each one of them. So that's going to be 0 for our first residual, 1, this is -3, 4, -5, -4, 6 minus 7 would be -1, and 8 minus 8 is 0. So I'm just doing subtraction on each of those, okay? And now I'm going to plot the x's and the residuals to see if I'm going to plot like xy pairs like this, okay? So I'm going to be plotting these. Okay, so 0, 0 would be the first x residual pair. Then 1, 1. Then I've got 2, -3. 3, 4. And this is 4, -5. 5, -4. This would be 6, -1. And 7, 0. Okay? So it's kind of a judgment call. Those are it's not quite so evenly dispersed here. So it's not as good as the last one, let's put it that way. So you could say yes or no and make an argument because it's just kind of a judgment call to say how evenly dispersed you think those points are. I'm going to say no, just in comparison to the last one, because those are spread more widely and it's not as even of a distribution. If you look at the one from the previous page, it was kind of doing, oscillating, going up and down above the XY axis, where here it kind of just made this bell curve down here, and it looks like another bell curve down there, up there. So it's not as good of a fit. Okay, so that means that line of fit doesn't fit the data quite as well. All right, on the last page of the notes, I'm going to show you how you can use a graphing calculator to write an equation for a line of fit. And it's actually going to be the line of best fit. Your calculator can make the calculation to make sure that's the best possible line for the data. Okay. If you don't have a graphing calculator, I'm going to use a calculator like this, a TI calculator, but you can find what's called a linear regression calculator very easily online. So if you just do a Google search or something, you'll find a linear regression calculator. And basically you're going to input these XY pairs and then tell your calculator or the program to write a line from there. Okay, so here's what we're going to do. To enter the data in one of these TI calculators, I'm going to hit the stat button first. So the stat button is near the top middle, right under the delete button there. My calculator went to sleep there. Okay, so I'm going to hit stat, and then I'm going to choose edit. So I'm in the edit column, and then the first thing in the edit column is edit. So I'm going to hit enter on that. Enter's in the bottom right corner of this calculator. All right, and then I've got L1, L2. I've got these are called different lists. And I've already got some numbers in here. This is just from something I did previously on the calculator. So you can go through and clear those entries one by one. You could hit the clear button and then enter to do that. But what I like to do is clear everything out by using the cursors, and I'm highlighting L1. And if I hit clear on L1 and then enter, then it clears out all of those all at once. And I'm going to do the same thing with the second list with L2. I want to clear out all that stuff. You could actually write right on top of those entries too. That's another way you could handle it. Okay, so L1 is going to be my x's. So I'm going to set up this XY table in my calculator. So I'm going to hit 0 and then nothing happens. But if you see at the bottom right there, it says, okay, in that entry, it's showing 0, but I actually have to hit enter for it to show up in the list. Okay, and then so I'm hitting 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, and then it goes all the way down there. Okay, and I don't want a 6th entry there, so when you get to the bottom there, just scroll to the right to go to the L2, to list 2. That's going to be our y's, and I'm going to do 6, 4.5, 3, 3.5, 4, and 2. Also, just for future reference, there's no negative numbers in this XY table, but if you did have a negative, you don't want to use the minus, the subtraction button. You want to, because we're not subtracting anything, you'd use this button right by the decimal point. So it'd be the negative that's in parentheses down there. If I wanted to type in -3, I'd hit that and then that, okay? Otherwise, you'll get an error on your calculator. All right, so our XY table is in there. So now I want to write the equation. So what I'm going to do is go back to the stat menu. This is going to stay saved in my calculator. So I'm going to go to a different screen, but that's still going to be entered in the calculator. So I'm going to hit the stat button again, just like I did before. But this time I'm not going to do edit. I'm going to do I'm going to go to the calc column, that second column over. I'm just going to do that with the cursors. I'm going to go to the right, okay? And then I want to do a linear regression. So if you scroll down, you see this fourth thing. This fourth thing that I can choose says lin reg, and then it says ax plus b. Okay, that was a lowercase a, but whatever. Okay, so I'm choosing this command. So I'm hitting enter when I'm on that. And then this is just saying which list it's going to use. It should default to list 1 and list 2. So you can usually just press enter a bunch of times or just scroll past this until you get to calculate. And if you hit enter here, then it's going to spit out a bunch of numbers. So what this is doing is it's saying, okay, we've got an equation in this format. So I don't know why they don't just say mx plus b, but it's y equals ax plus b. And then they tell us what the a and the b are. So then I can plug in -0.6 for a, and then my b is 5.3 repeating. So 5 1/3. I'm just going to put a bar over the 3 to show those 3's repeat. And there is my line of best fit. Okay. All right. The correlation coefficient is going to describe how good this line of fit is, all right? And so the correlation coefficient is going to be the R, and it's on the screen here, okay? So this is going to be represented by R, all right? And a correlation coefficient that is close to 1 has a strong positive correlation. And if it's close to -1, it's going to have a strong negative correlation. Okay, so if you 0.99 or something like that would have a strong positive correlation, negative 0.99 would have a strong -1. Okay, but if you a correlation of close to this should really say close to 0. That's an error on there. If close to 0 has no correlation. Okay, so just to put this on a little graph here, if I have -1 and +1 and then 0's in the middle, it's always going to be between -1 and +1. This would be negative, positive, and none. So it's a little bit arbitrary. It's like, are you closer? You know, sometimes you might have something like 0.5. It's kind of a weak positive, or a negative 0.5 would be a weak -1. Okay, I'll fix this typo on the note-taking guide. All right, so now we're going to use the calculator to find the correlation coefficient for the equation from part A. So I've already done this calculation, and R is on my screen. So R is about negative 0.82. Okay? Now, some calculators, it might not show the R. And I'm going to show you how you can get the R on there if it's not on there. So you're going to go to the catalog in your, it's just on these types of calculators, but the catalog, there's little blue writing here right above the 0. It says catalog. So I'm going to hit the second button to use, then I can use that blue writing that's above the number 0. So I hit second and then 0. This is my catalog, and then I'm going to go find diagnostic on. So it's going to take some scrolling, and my diagnostic is already on. So let's see. Let me hold this down a while. Okay, so you can turn diagnostic off or on. You want it on. Mine's on already, and that's why it shows the R's. But if yours didn't show the R's, and then you'd hit enter, you hit enter, and then you hit enter again to make it run. Then you'd have to go back and do the linear regression. So if I go to stat, calc, linear regression, and then you should have the R's on there. Don't worry about the R squared. We don't need that for now. But the R is the negative 0.82. So I can see that this has a negative correlation. Okay, so now let's use the line of fit from part A to predict what y equals when x equals 12. So at the this is off the top of the screen, but in part A we found that y is negative 0.6x plus 5.3 repeating. So now what I'm going to do is plug in 12 for x and see what y is going to equal. Okay, so I'll just use my calculator to make this quick. So negative 0.6, and by the way, I used that negative button down there, not the minus. I'm not subtracting 0.6, it's just negative 0.6. So I use this times 12. All right, and then I'm going to add 5.3 repeating. I'll just put in a bunch of 3's to get this pretty close. I'm going to round my answer anyways. But this is going to be, y would be negative 1.86, and then those 6's are going to be repeating. Okay. All right. So let's predict what x equals when y equals 100. We can plug whatever we want in for x now. Okay, so I'll do the same kind of thing. I'm going to do negative 0.6 times 100, and then I'm going to add 5.33333. Something like that, and I can see it's going to be negative 54.6 repeating. Okay, and that's the idea. All right, that's the end of the section, and I'll see you next time.